So in this lecture now, we're going to expand upon some of the ideas of conformational analysis, such as steric contortional strain that we defined in the previous video. Now we're going to look at a specific example with this compound 1,2-dibromoethane. So the most useful representation of acyclic molecules for understanding conformational analysis is a Newman projection. And we're going to produce multiple Newman projections for this single molecule below. So the Newman projection is going to focus on the projected bond, which is going to be the carbon-carbon bond here. And this carbon atom, we're going to look at from the perspective of the eyeball. If you were in the plane of the page, staring at that red carbon, then there would be a green carbon directly behind it. So the projected bond here is the C1-C2 bond of 1,2-dibromoethane. Now, because each of these carbons is sp3 hybridized, they have 4 sigma bonds and are tetrahedral. So one hydrogen comes out of the plane as a wedge, and the other goes into the plane as a dash at each carbon atom. And currently, we have the bromines exactly parallel with one another, or there's a 0-degree dihedral angle between the carbon-bromine bonds. So this is said to be an eclipsed conformation, or those two bonds are eclipsing one another.